Stop. Before you watch another space disaster movie, there is something fundamental you need to understand, because everything you think you know about dying in space is wrong. Not slightly wrong, not off by a small margin. Completely, systematically, and entertainingly wrong. You have a picture born into your brain, a tiny crack appears in the hull of a space station, and within seconds, a monstrous invisible force rips astronauts from their seats and swallows them into the darkness. You have been sold the idea that the void of space is a hungry predator, a cosmic vacuum cleaner pulling everything toward it with unstoppable violence. That image is a complete lie. And today, I am going to replace it with something far more unsettling, far more precise, and infinitely more fascinating: the actual physics. The fundamental mistake that almost every human being makes is believing that the void has force, that nothingness has the ability to pull. I have spent my life studying the structure of space and time, and I can assure you with absolute certainty that the vacuum of space does not suck anything. The vacuum is, by definition, the total absence of pressure. It has no will, no energy, no invisible hands. It is, quite literally, nothing. So if outer space is not pulling at you, what is actually happening when a spacecraft hull is breached? Why does air rush toward the darkness? The answer is far deeper than the movies suggest, and it forces us to look inward rather than outward. The violence does not come from the infinite abyss of the cosmos. It comes from the very container you are sealed inside. It comes from the air you breathe. Think about the International Space Station, not as a marvel of modern technology, but as what it fundamentally is from a basic thermodynamics perspective. It is simply a thick metal balloon floating in absolute nothingness. Inside that balloon, we have packed gas, ordinary air, oxygen, and nitrogen molecules bouncing constantly at thousands of kilometers per hour against walls of titanium and aluminum. That relentless, ceaseless thermal agitation of molecules pushing outward is what you call pressure. Outside, in space, there is none of that. There are zero molecules bouncing. There is exactly zero pressure. This is where human intuition fails completely, and I have watched brilliant physics students stumble over this precise point. The force that moves air through a breach does not depend on the immensity of the exterior vacuum. The infinite size of the cosmos is entirely irrelevant to the equation. Fluid dynamics dictates that the escape force depends exclusively and mathematically on the pressure difference between interior and exterior. And what is that difference in space? We maintain our spacecraft at 1 atmosphere of pressure, exactly the same as here on Earth at sea level. Outside, the absolute pressure is zero. Therefore, the pressure difference is exactly 1 atmosphere. Just one. Now apply pure mathematical logic. Is 1 atmosphere of pressure a demonic force capable of bending steel and tearing flesh from bone? Let me demonstrate with something sitting in your garage right now. Take a standard car tire. The air pressure pushing outward inside that tire is generally 2 to 3 atmospheres, double or triple the expansion force experienced by a spacecraft relative to the vacuum. If you puncture that inflated tire with a thick nail, does the hole violently suck your hand or your dog inward? Of course not. The air escapes outward with force. It is fast, it is loud, it is completely predictable. It is physics, not dark magic. Imagine a small meteorite punches through our spacecraft hull and leaves a coin-sized hole. The physics occurring in that instant is ruthless but extraordinarily ordered. Air molecules that happen to be bouncing near that opening simply stop hitting metal and continue traveling in a straight line toward the darkness. The remaining cabin air rushes to fill that new space, creating a current, an internal wind. If you are near the perforation, you will feel a violent breeze pushing you in that direction. But here is the part that is genuinely fascinating. If you place your bare palm directly over that hole, you would feel the internal air pressure pushing your flesh against the metal edge. And you know exactly what would happen. Your hand would seal the breach instantly without critical injury. A 1 atmosphere pressure difference translates to roughly 1 kilogram of force per square centimeter. Over a coin-sized opening, the total force pushing your hand toward the void would be just 3 or 4 kilograms. You could hold 3 kilograms with a single finger. Plugging a leak into outer space requires so little force that the reality is almost anticlimactic. And this anticlimactic reality forces us to dismantle the second absurd myth that genuinely angers me every time I see it repeated on screen. The idea that the human body explodes in a vacuum like a carnival balloon, this is an inexcusable offense to basic biology. Your skin is not a sheet of brittle paper. It is an organ of extraordinary evolutionary engineering, densely woven and elastic, built over millions of years specifically to keep all your internal fluids under pressure and your cellular contents contained. If someone ejected you into outer space without a suit, The pressure difference across your tissues would be, as I just demonstrated, only 1 atmosphere. Your skin can resist that mechanical tension without meaningful structural effort. You will swell somewhat. The gas trapped in your lungs and intestines will expand, forcing your torso to distend, but you will not explode into pieces. Structurally, you will remain physically intact as a single continuous unit. So here we arrive at the real question. If the vacuum does not suck you like a cosmic vacuum cleaner, and if your body's structural integrity survives without shattering into fragments, where does the actual danger lie? Why would death reach you in a terrifyingly short window of time? The true threat, the one from which there is no escape, has absolutely nothing to do with the mechanical force of air pressure. It has everything to do with a brutal thermodynamic phase transition that would begin occurring just beneath your own skin the instant you were exposed. Consider the temperature of your own body. Right now, you are at approximately 37 degrees Celsius. That is the warmth of biology functioning correctly. But in the vacuum of space, those 37 degrees become your death sentence, governed by a physical law you experience and completely ignore every single morning when you make coffee. Let us talk about how water boils. Most people believe water boils simply because it is hot enough 100 degrees Celsius, and that is the end of the story. But heat is only half of the equation. Temperature measures the agitation of water molecules. When you heat them, those molecules want to separate and become gas. But something holds them in a liquid state, crushing them from above. That something is the atmosphere pressing downward. Boiling occurs at the precise moment when the vapor pressure of water equals and overcomes the surrounding atmospheric pressure. It is a constant battle between thermal energy pushing upward and atmospheric pressure pushing downward. Now remove one side of that battle entirely. Eliminate the air. Drive atmospheric pressure to absolute zero. If external pressure is zero, water molecules no longer need to reach 100 degrees to overcome their environment. They need almost no thermal energy at all. At zero pressure, the boiling point of water drops so dramatically that water can boil while remaining ridiculously cold. And here is where thermodynamics turns against you in the most intimate and personal way imaginable. In a vacuum, the boiling point drops well below the 37 degrees Celsius of your own body. This means that the instant you are exposed to the spatial vacuum, every exposed fluid in your body begins boiling simultaneously. Not because it is being burned, but because the environment can no longer maintain those fluids in a liquid state. This is a perfectly documented phenomenon called ebullism. A real incident occurred in the 1960s inside a massive vacuum chamber on Earth, where a technician was accidentally exposed to near total vacuum due to a disconnected soot tube. Before losing consciousness, the last conscious sensation he reported was physically feeling his saliva boiling and bubbling on his own tongue. That is not a horror story invented to frighten children. That is basic thermodynamics applied to the moisture inside a human mouth. But I told you earlier that your body does not explode, and I stand by that completely. Your skin is a naturally pressurized suit of high-order biological engineering. Your cardiovascular system maintains blood at a pressure higher than the surrounding environment, so your blood will not begin boiling in those first moments. Your veins will not immediately become pressurized gas tubes. The real threat is far more insidious, faster, and attacks the single most vulnerable point in your evolutionary design. The critical problem, the fatal flaw, occurs in the one location of your body, specifically designed to be open and exchange gases with the exterior, your lungs. Your lungs are a vast and delicate network of microscopic sacs. On Earth, their function is beautifully simple: allow oxygen to pass into the bloodstream and carbon dioxide to exit. But in space, the physics of fluid dynamics inverts itself with implacable mathematical brutality. Remember our rule of pressure differential. You have air at 1 atmosphere of pressure trapped in your lungs and 0 pressure outside. Here is the critical point. If your animal survival instinct tells you to hold your breath, if you close your throat with every ounce of force to preserve that precious air, you are committing the last and worst mistake of your life. That single atmosphere of difference we discussed is more than sufficient to destroy lung tissue from the inside. The confined air expands, seeking escape with enough force to rupture the fragile alveoli, driving gas bubbles directly into the bloodstream, straight toward the heart and brain, a massive instantaneous embolism. Your own survival instinct would kill you in 2 seconds. The only way to survive those first moments, the only logically and physically correct action, is to exhale completely, to voluntarily empty your lungs toward the lethal abyss, to scream every molecule of oxygen into the nothingness. It is profoundly counterintuitive. It is absolutely terrifying, but it is the only mathematically sound decision that preserves your internal structural integrity. But by doing the right thing, by exhaling, you immediately face the next unavoidable wall. You have saved your lungs from rupture, but you have emptied yourself of the element that fuels your consciousness. The biological clock accelerates beyond recognition. You no longer have minutes. You have a handful of seconds. And the paradox of what happens to your blood in the 14 seconds that follow is what truly defines the boundary of our conscious existence in the universe. You have just done the unthinkable. You have emptied your lungs into the absolute vacuum of space. Your primate instinct screams that you have committed immediate suicide. But strict physics tells you that you have bought time and avoided an explosive embolism. Yet this is where human biology collides head-on with thermodynamics in a genuinely macabre paradox. You might believe that even with empty lungs, you still retain the oxygen already circulating through your arteries and veins. You might imagine you could survive the agonizing minutes that a deep-sea diver endures holding their breath underwater. You would be profoundly mistaken. Your own body is going to betray you, doing so by following the immutable laws of gas diffusion with absolute and lethal perfection. To understand the brutality of this paradox, we need to examine the mathematical mechanics of your lungs on Earth. They are not mechanical pumps. They are passive membranes. Gas exchange functions exclusively through partial pressure gradients. Think of it like water always flowing downhill due to gravity. On Earth, the air you breathe carries a high partial pressure of oxygen. Your blood arrives at the lungs from the rest of the body carrying low oxygen pressure. By pure physical obligation, oxygen flows downhill, crossing the membrane from your lung air into your bloodstream. It is an elegantly simple system built entirely on a pressure difference. But observe what happens the instant absolute nothingness surrounds you. You have exhaled. The pressure of any gas in your lungs is now exactly zero, absolute zero. And that dark venous blood, your heart, oblivious to the catastrophe, keeps sending to your lungs to collect fresh oxygen. That blood still contains dissolved oxygen molecules, still carries a substantial partial pressure, far greater than the absolute vacuum now reigning inside your chest. Visualize the mathematical disaster unfolding in that precise instant. The pressure hill has completely inverted. The gradient has reversed direction. Instead of oxygen flowing peacefully from lungs into blood, physics demands equilibrium in the opposite direction. The remaining vital oxygen in your bloodstream is literally ripped across the capillary membranes and expelled into the vacuum of your own lungs, lost to space forever. Your lungs, the biological organ perfected across millions of years of evolution to inject life into your body, have just become the perfect machine for extracting and eliminating the last trace of oxygen from your veins. Your own respiratory system is suffocating you from the inside out with an efficiency that no external mechanism could ever rival. And your heart has no way of knowing the universe has changed. The heart is a blind and obedient muscle. It keeps beating, powerfully pumping this freshly purged and completely useless blood back into the main circulation. And the first consumer in line to receive this torrent of oxygen-depleted blood is the most delicate organ of all, your brain. Your brain is the most demanding biological machine in the known cosmos. It consumes a massive amount of oxygen in real time and has absolutely no capacity to store even a single reserve molecule. It operates strictly on the supply it receives second by second. Blood takes a very specific transit time to travel from the pulmonary alveoli, cross the left chambers of the heart, and ascend through the carotid arteries to bathe the neurons of your cerebral cortex. I have calculated this number, and aerospace physicians confirm it. 14 seconds, not 15, not 20, exactly 14 seconds. That is the total window of your functional consciousness. During those 14 heartbeats, you will be awake. You will feel the ebullition in your mouth. You will observe the starry darkness without distortion. But at second 15, when that wave of oxygen-stripped blood impacts your neural network, there will be no gradual, romantic asphyxiation. The loss of consciousness will be mechanical, instantaneous, and absolute, as if someone cut the main power cable of a computer server. Your mind simply switches off. But listen carefully, because the collapse of your consciousness does not mean entropy has finished with you. Biologically, you remain alive. Your heart continues beating on cellular inertia, and your body continues functioning as a closed thermodynamic system thrown into the most extreme environment conceivable. And this is where most people commit the most embarrassing logical error when imagining space. They believe you will instantly freeze solid and become a drifting block of ice. That misconception is so large it offends the physics, and I am about to dismantle it completely. You are floating in the darkness. Your mind switched off mechanically at exactly 14 seconds. Now, common sense and popular culture insist you become an ice sculpture instantaneously. After all, deep space sits at around minus 270 degrees Celsius. It is the coldest environment in the known universe. Any rational person would assume freezing is simultaneous with death. I assure you that is a complete physical absurdity. It is a total misinterpretation of what temperature actually means. You need to break the mental association between space and cold. Outer space is not cold. Outer space is the absence of things, and nothingness has no temperature. For you to feel cold on Earth, you need to be in direct contact with matter. When you jump into an icy lake, dense water molecules collide furiously with your skin, stealing your thermal energy through conduction. The water is full of mass, which is exactly why it extracts your heat and chills you so quickly. During a blizzard, the winter wind does the same through convection, continuously sweeping energy away from your body. Cold on Earth is a physical theft perpetrated by the atoms surrounding you. But examine the abyss you now inhabit. In the vacuum of space, there are no molecules, no water, no wind, no air, absolutely nothing material that can touch your skin to absorb your heat. Think about the engineering of a thermos flask. How does that cylinder keep a boiling liquid hot for an entire day? Its design is brilliant in its simplicity. It has a double steel wall, and in the middle, engineers have extracted nearly all the air, creating a partial vacuum layer. The vacuum turns out to be the most perfect thermal insulator that exists in classical physics. When you drift through outer space, you are that hot coffee trapped inside nature's ultimate thermos. You are thermally shielded from the universe by the immensity of nothingness itself. So, if there is no conduction and no convection, how exactly is your body supposed to lose its 37 degrees of biological heat? The only physically and mathematically available pathway for a completely isolated human body in vacuum is thermal radiation. Your body is forced to shed its energy by emitting infrared light photons slowly toward the infinite darkness. And thermal radiation at biological temperatures is an overwhelmingly inefficient and desperately slow process. It does not happen in seconds or minutes. An adult human body floating in the complete shadow of deep space would take many hours, possibly entire days, to radiate enough infrared energy to freeze through to its core. It would be a painfully lethargic cooling process. In fact, the physics reveals that your real problem could be precisely the opposite of extreme cold. If you are exposed to direct sunlight in Earth's orbit, the situation becomes brutal in an entirely different direction. Without a planetary atmosphere to disperse and filter the raw electromagnetic radiation from our star, your skin would absorb thermal energy at a devastating rate. You would overheat massively, slowly roasting on the sun-facing side, while the shadow-facing side gradually surrenders its biological heat over hours. Becoming a brittle block of ice instantly is a cinematically lazy lie that genuinely irritates me to have to correct. But I do not want you celebrating this thermal victory, because the fact that your body retains its natural warmth rather than freezing quickly is precisely what guarantees your internal destruction continues without mercy. Remember the pressure paradox we established earlier. Your blood, now stagnating as your oxygen-deprived heart begins to fail, is still sitting at a warm and comfortable 37 degrees Celsius. And the vacuum continues pressing with mathematical certainty from the exterior. The retention of your own body heat is the catalyst for the final thermodynamic horror. You are warm, you are isolated, you are in vacuum, and that precise combination is the exact recipe for the water inside your deep tissues to initiate an unstoppable phase transition. The boiling has not stopped, it has merely been finding its way toward your blood. This brings us to a medical and thermodynamic concept that is both undeniable and genuinely terrifying: the Armstrong limit. This limit is named after an aerospace physician who understood something profoundly disturbing in the mid-20th century. He discovered that the dense atmospheric pressure under which we live is not simply something that allows us to breathe on Earth. It is the invisible physical shield pressing against our bodies that keeps our vital fluids in a liquid state. At sea level, pressure is high. As you ascend in altitude, atmospheric pressure drops. If you could rise to approximately 19 kilometers above Earth's surface, you would cross an invisible mathematical line. That is the Armstrong limit. At that exact altitude, ambient pressure falls below the vapor pressure of water at 37 degrees Celsius, the precise temperature of human blood. In the deep spatial vacuum, you are infinitely beyond that limit. You are at absolute ground zero. Your cardiovascular system is a closed hydraulic circuit. During those first lethal seconds in vacuum, the elastic tension of your arteries and veins offers some resistance. Your internal blood pressure, generated by your heart, exceeds the exterior pressure, which delays total systemic collapse. But when your brain shuts down and your heart, starved of the oxygen you exhaled, begins beating erratically and losing its pumping strength, the pressure inside your own blood vessels collapses rapidly. And then thermodynamics delivers its inevitable sentence. The water in your blood plasma no longer has any physical force compelling it to remain liquid. It begins boiling, not metaphorically, it literally changes phase to gas inside your deep venous network. Visualize the physics of any mechanical pumping system. Your heart is the central pump of the machine. For a hydraulic pump to function efficiently, it needs liquid. Liquid is incompressible. When the thick cardiac muscle contracts, it pushes blood forward with flawless mechanical precision. But now, under zero pressure, enormous water vapor bubbles, a highly compressible gas, flood the atria and ventricles of your heart. This causes a total mechanical failure known in fluid engineering as vapor lock or cavitation. Your heart continues beating desperately on pure cellular survival instinct, but its vigorous contractions now only succeed in compressing and expanding useless gas inside the valves. It is exactly like flooring the accelerator of a vehicle with a completely destroyed transmission. Enormous energy expenditure, zero forward movement. Within a pair of heartbeats, your blood pressure, the force sustaining the entire architectural structure of your biology, drops to absolute zero. Your blood stops flowing permanently. Simultaneously, the newly formed water vapor demands space, far more physical space than it occupied as liquid plasma, and it has nowhere to go. It is trapped beneath your biological spacesuit of skin.